Hello students, let's talk about vertex form. When you have an equation in this form, y equals x minus h squared plus k, it will always have a vertex of h and k. Basically, you put a number in for h and a number in for k, the opposite x will be the x coordinate of your vertex, and the same y, the same number here will be the y value of your vertex. So here are the two equations graphed. Now these equations we solve by completing the square. You might notice that the numbers that are our vertex are also the numbers that kind of show up in our process when we solve by completing the square. But as you can see, I have x squared plus 6x minus 20 graphed. Its vertex is, I'll write it down here, the vertex is -3 and -29. Okay, cool. And then the vertex for x squared minus 8x minus 44, the vertex is 4 and -16. Now, where does vertex form come from? So like I said, we solved these equations by completing the square. We got the solutions. This is a screenshot of Desmos, so it's not live, sorry. So we found those values. Well, when people were messing around with completing the square, they found out that the vertex numbers kind of showed up when they were doing some of the work. So they're like, well, why don't we just make this brand new form and call it vertex form so it shows the vertex every time? And the other math people are like, sweet, go for it. All right, so let me kind of show you what they stumbled upon. They did about the same number of steps, but then they just kind of turned left when everybody else turned right. So let me show you what I'm talking about. If you were going to complete the square, normally you would set it equal to 0, but let's set it equal to y instead. So the first step would be to vacate that extra number, so you would add 20 to both sides. Rewrite it as y plus 20 equals x squared plus 6x, and then you made some space, right? All right, so go ahead and complete the square. 6 divided by 2 squared is 9, so you would add 9 right here. You would add 9 right there. Okay, quick rewrite. Y plus 29 equals, weird, 29, 29, interesting. And then if you rewrite this as a binomial, this is actually x plus 3 squared. Interesting. 3 and 29. So that's what they were finding out. They were finding out that when they were doing their whole complete the square method, they're like, yo, dude, like the numbers in our work are showing up as the vertex. Interesting. So they're like, well, how can we make it look like an actual equation? It almost looks like an equation. It just looks like a bunch of random numbers now. How about we solve for y? So they decided to subtract this extra number from both sides. And you have y now equals x plus 3 squared minus 29. So again, as mentioned, here's the plus 3. If it's plus 3 inside the equation, inside the form, you're going to hit the opposite value. So if it's plus 3, you're going to hit -3 for a vertex, your x-coordinate point. And on the outside, if it's minus 29, that's going to be your y value of your vertex. So kind of interesting stuff. So I think this is like the first 3 steps, and then they, instead of like square rooting, they just kind of pumped the brakes and said, stop, look at these numbers. These numbers are the vertex with a little bit of switching and then, well, copy and paste. So opposite x, same y. Opposite x, same y. The same thing happens when we do the same thing to this equation. 4 and -60, where does that show up? How do those numbers come out of all this noise? Well, first move is you would vacate that 44. We got to make room to complete the square, but it's not equal to 0, it's equal to y. Okay, whoops, made a mistake. Go away. I need to go plus 44, silly goose. Plus 44, that's going to equal x squared minus 8x blank. We need to complete the square. We did this on the previous example, so -8 divided by 2 is -4. -4 squared would be a positive 16. Add 16 to both sides. Ooh, it's starting to take shape. This is going to be y plus 60. Ooh, interesting. Equals, rewrite this as a binomial squared. This would be x minus 4 squared. Ooh, it's so close. All right, we got to subtract the 60 from both sides. Minus the 60. Y is all by itself. It equals x minus 4, close the bracket, square it, minus 60. Again, the opposite x says minus 4. That means your vertex is going to be positive 4. And if it says minus 60, your y coordinate of your vertex is going to be minus 60. So again, opposite x, same y. So that's vertex form. They found out as they were completing the square that the vertex's numbers were showing up in the math. So they're like, dude, let's make a brand new form and call it vertex form. It's kind of neat. You can bullseye any coordinate point with a curved line now with a vertex form. It's pretty powerful. It looks pretty simple, and it'll bullseye any coordinate point with a parabola. So nice, cool. That's vertex form. So the big thing to take away, opposite x, and same y. Okay, cool. See you in class.